Question 3, the first bit. What part of an atom is the same as a beta minus particle? Well, that's something dead easy, you should know that. If you don't know it, it's on page 7 of the textbook. But it also means you've got to get on with doing some revision pretty sharpish before your exam. So the next part is referring to this nucleus here, unknown element, X, that's got a proton number of Z and a nucleon number of A. If X decays by a beta decay, how does A change and how does Z change? Let's remember what's happening in the nucleus when a beta particle is emitted. Remember that in the nucleus, you've only got protons and neutrons, and when a beta particle is emitted, it's one of those particles has changed into the other sort. So there'll be a change in the number of protons. You've got to decide, does the number of protons go up or go down? Has a proton turned into a neutron, or has a neutron turned into a proton? And then for the change in the nucleon number A is the total number of protons and neutrons. And since what's happened is that one particle of one sort has turned into a particle of the other sort, what does that do to the total number of them added together? Part B, in the process of beta minus decay, an antineutrino is also released, and it says give an equation for this decay. Now the thing we're working with this nucleus A and Z, so you could write that with your equation A and Z. Alternatively, we are talking about beta decay in general, so in beta decay in general you could do it, we said it involves protons and neutrons, so you could write the equation so it's got protons and neutrons in it, or A proton and A neutron if you want, or even if you really wanted to, we know that what really goes on in beta decay is quarks changing, so you could actually write your equation in terms of the sorts of quarks that change. It's up to you. 3b, state and explain which conservation law may be used to show that it is an antineutrino rather than a neutrino that is released. So the conservation laws, those are the things that we normally expect to stay constant in a reaction or in a change. So we've got charge, for instance, is one of the things that is normally conserved. Baryon number is one of the things that's normally conserved. There's something else that's also conserved. You need to explain what that law is and then show that it works. 3b2, this is the sort of question that you're going to be tempted just to ignore and pass over and assume that you'd be able to do something in an exam, but it's important that you do practice expressing these answers. What must be done to validate the predictions of an unconfirmed scientific theory? Anybody can come up with a scientific theory, doesn't mean it's going to be right, doesn't mean it deserves taken seriously. So what do we have to do to validate a theory? Remember, we can never prove a theory right by experiment, but it's important that experiments are done to validate it. So you need to explain why that is. So you have to mention you've got to do an experiment. The mark scheme says that the experiment's got to be repeatable. So it's no good just doing something once. If an experiment can be done repeatedly and give results that support the theory, we'll continue to accept the theory. If an experiment can't be done and consistently give results that support the theory, then we'll reject the theory.